So now we want to multiply these two measurements together. So I've got two measurements, 5.6 plus or minus 0.2 and 2.7 plus or minus 0.2. So now I want to multiply them together. Okay, we're going to use the Pythagoras, basically going to use Pythagoras again, like when we did adding the uncertainties. However, we have to use Pythagoras using the percentages. So I have to convert these from an absolute value into a percent value. So sigma 1, well, P1, we're going to call it percentage 1, is equal to 0.2 over 5.6 times 100. So calculate time, 0.2 divided by 5.6 times 100 equals 3.571%. There's no point in carrying on with uncertainty because we're only going with these figures because we're only going to give the answer to one significant figure anyway. So if we go too far down there, so that's plus or minus 3.571%. And then we do percentage 2, that's going to be 0.2 over 2.7, so it's going to be quite a large uncertainty, times 100, equals 0.2 divided by 2.7 times 100 equals 7.407%, plus or minus 7.407%. And then, to get the percentage uncertainty, P equals, we take the square root of P1 squared plus P2 squared, just like we'd do when we're using Pythagoras. So that's going to equal the square root of 3.571% squared plus 7.407% squared, and we take the square root, so we got 3.571 squared plus 7.407 squared equals, take the square root of that, equals 8.223%. Now to turn that uncertainty back into an absolute value, we find out the answer here, so that's going to be 5.6 times 2.7 equals 15.12 plus or minus 8.223%. So to find out the final uncertainty, we go 15.12 times 8.223 divided by 100. After all, that's what percent means. It means this number divided by percent per 100 equals times 8.223 divided by 100 equals 1.2433. So sigma, this is going to be the actual uncertainty. So sigma is going to, remember we round this to one significant figure, so it's going to be plus or minus 1. So this is going to be plus or minus 1. And now remember, there is no point in giving this number to more decimal places than the uncertainty, because this 0.12 can be anywhere within that uncertainty. We're just going to round this to 15 plus or minus 1. Well, if you have three numbers that you're multiplying together, remember again with Pythagoras, just like we did in the adding, you can do Pythagoras with any amount of percentages in there, plus dot dot dot. So you just square the percentage of the first one, add that to the second percentage squared, add that to the third percentage squared, as many as you got. Then once you've done that, you take the square root of the lot, and that will give you the percentage uncertainty. So our final answer for these two numbers is going to be 15 plus or minus 1. So what happens if you're going to divide two numbers? So let's go 7.6 plus minus 0.4 over divided by 3.1 plus minus 0.2. How do we divide and get the uncertainties when we're dividing? We're going to do that exactly the same way as when we multiply. So the first thing is first we figure out what the base values are. 7.6 divided by 3.1 equals 2.4516. Probably no point going further than that at the moment. And then what we're going to do is we're going to take the uncertainties and turn them into percentages. So P1 equals 0.4 over 7.6 times 100. 4 divided by 7.6 equals times 100 equals 5.263%. P2 is going to be is going to equal 0.2 divided by 3.1 times 100 equals 0.2 divided by 3.1 times 100 because it's a percent. 6.452%. We add them together. P is equal to root of P1 squared plus P2 squared, which is equal to the root of 5.263% squared plus 6.452% squared. So let's do that again. 5.263 squared plus 6.452 squared equals, take the square root of that lot, equals 8.326%. Now remember, we multiply the amount, so we're going to, but now we have to convert that into an absolute uncertainty, and it's uncertainty within a unit basically. So we're going to go 2.4516 times 8.326% equals times 2.4516 equals divided by 100, 0.204. Remember, we round this, so the uncertainty is going to equal 0.2 because we only do it to one significant figure. And then, so it's going to be plus or minus 0.2. There's no point in giving this data to any more than one decimal place. You give this information here to the same number of decimal places as your uncertainty. So that becomes 2.5 plus or minus 0.2.